How's everyone doing? So I'm Alexandra, and in this session, we'll get a flavor of what topic modeling is, why you might want to do it, as well as some approaches. Joey has already done a great introduction, but a little bit more about me. In my past life, I was in the public sector where I did international policy. And I researched on trends affecting Singapore's maritime future. And then I did a career pivot. So now I'm applying my curiosity about trends and signals about future as a cultural data scientist at Synthesis. And also, yes, shout out to the Google folks. Also proud graduate of the Google Women Developers Academy. And it's a really wonderful initiative helping women in tech become even better tech presenters. So recommend checking that out. And in my free time, I volunteer with She Loves Data and the Women in Tech group as a blog editor where I help collect inspiring stories for the community. Right. So let's just begin with a kind of motivating example. Let's say we are an e-commerce business and we have our dedicated Twitter handle to answer customers' requests. And what we want to do is to get some kind of structure out of unstructured textual data, the tweets, and this is where topic modeling can come in. So why does it matter? And this is the part where we connect the data science part of the equation to the business value. So according to this marketing research on HubSpot, about 90% of customers, they rate having an immediate response as either important or very important when they have a question. And I mean, everyone's been a customer at some point, so you can imagine you just don't want to be left hanging. So first thing to get is that topic modeling is different from rule-based text mining approaches like using dictionary for keyword matching to get certain themes, for instance. It's an unsupervised method that detects patterns on co-occurring terms. So this means that it can help us find common themes or concepts in the textual data, even we're not quite sure about what we're looking out for. And to do this, I used Tweepy and a Twitter API to gather tweets seeking customer support from a certain e-commerce platform. And to focus my query, I only included tweets that were sent to the platform's dedicated Twitter handle for customer support, and retweets were excluded. So the next step is to clean and standardize the data set because we want to make our models perform better. So I use Regex and Spacey, which is an NLP library. And this involves removing things like URLs, as well as stop words like there and other kinds of noise, followed by lemmatization, which is getting the root form of a word. And then sometimes words are more meaningful when you consider them together as a phrase. And for this, I turn to the Gensim library. So I use it to identify words that co-occur more frequently than you would expect them to by random chance. And this includes things like delivery attempt and poor service. So I took 3 different approaches, and more of those approaches in a bit. The thing with topic modeling is that you generally have to predetermine the number of topics in advance. I chose 10, and this is based on coherence metric that measures the degree of similarity semantically of the keywords within a topic. I built and ran a Latent Dirichlet allocation model for the baseline. And this is a model that associates each document, which is a tweet in our case, with a probability distribution over topics. And the topics themselves are probability distribution over words. And then for comparison, I built 2 other models. So one is the Biterm model, and unlike the LDA, it infers topics based on like the co-occurrences of word pairs that occurs across the entire collection of tweets. And this model was actually designed to overcome the data sparsity issue that you tend to face in short documents like tweets. So in other words, it views like the whole collection of Biterms as a mixture of topics, whereas LDA would see each document, each tweet as a mixture of various topics. And then another model is the Non-Negative Matrix Factorisation model. And essentially what we're doing is that we're treating this as an optimization problem using linear algebra. So it also sees the document, the tweet, as a mixture of topic, but it uses a different mathematical framework. And usually it's a bit faster to run. So To visualize the result, we can use a dimensionality reduction method like t-SNEEZE, but it's more interesting to tend to draw straight into the topics and the common words that emerge. I'll be focusing more on the non-negative matrix factorization because that was the one that gave the most human interpretable results out of the three. And there are actually different ways in which you can evaluate topic models. I went with the one which gave the most like human sense because we're doing this more for exploratory data analysis. So what we can see is that one of the key topics is on refunds, and this is often in relation to complaints about waiting for too long. So it's about under a third of tweets about that. And the top ranked terms, you can see words like time, refund, and product, for instance. And another one is where you have tweets that are about how the delivery status does not match what's actually happening in reality. And this is about slightly above 10% of the tweets. And here, the more common words would be things like deliver, say, package today. So just a few more on other topics. One of them is mainly about orders, about 10% of the tweets, and it ranges from demands to know why an order got canceled, or just requests for help to cancel the orders. And we can see that there's some overlaps with the earlier topic. And topic number 7 is about not receiving an email notification or reply. And topic number 8 is more about the link not working. So those are some of the more interesting topics that emerged. And we can see that topic modeling can be a good tool for doing this kind of exploratory data analysis. And we already can see that there are 2 sources of discontent, and in a way that suggests some kind of priority areas to address. So it might be worth investigating to see how we could streamline the current refund process, for instance. And there are also probably other lower hanging fruits, just making sure that as part of customer support protocol that your links are working. And yeah, we managed to uncover some kind of cool insights. Of course, there are limitations to using topic models. And as you can already see from the results earlier, that they will not produce highly nuanced classification of text. And the fact that it being an unsupervised method is kind of like a double-edged sword. So while we don't need to go through the effort of hand labeling a set of data for this algorithm to learn from, it also means that we generally can't guarantee the outputs. So they might line up with what we're looking for, they might not. And that is to say that, in short, it's just always best to try out different methods, especially when doing text analysis. And in fact, a big part of it is in the pre-processing and the cleaning of the data set part. So yeah, thank you.
So the first one is, how do you define noise and how do you remove noise from a given set of text?
Sure. I'll tackle the first part, which is more about the kind of noise. So essentially, how noise would be anything that will lower their topic quality or their ability to make it human interpretable. And for instance here, part of the noise include the e-commerce platform names, because it's going to come up in every kind of tweet. So I had to create a customized stop word list, and I included the e-commerce platform in that, for instance. And other things would be just either removing URLs, like I mentioned, or just, there's certain things that you can do as part of standard text pre-processing methods. I mentioned lemmatization. There's also stemming. And it's just a way to kind of standardize your text so that it's just easier to get cleaner results at the end of your topic modeling.
If the customer's explanation is filled with jargon but is urgent, how would you extract and categorize it?
So I think this question assumes that we're doing the topic modeling more in real time, but in the example I'm giving, it's not. So we're not facing that issue. And the idea is that if you want to create something that can respond real time, because there are a lot of other components to think of as well, including the deployment, certain aspects to do with more of software engineering side, because it may work fine when you have your team or data scientists are working on it, but then it's a different issue altogether when you're deploying it. So then you have to just decide what are trade-offs that you are happy to live with.
Is a bot being used to reply real time back to the tweets, or are they prioritized in a queue and highlight most urgent ones to customer support?
Yeah, so the answer is that there is no bot because there is no real time in this example. Yeah.
Vina asked how to analyze some words that will have ambiguous meaning.
Right. So this is a really interesting one, and thank you for asking that, Sabina. So the topic models that I use here, it treats like a bag of words. So you get the context more from the other surrounding words, and that's one way to deal with the ambiguity of it. There are other like more advanced model in which you use kind of like word embeddings in order to detect the actual context in which is being used. So again, there are different trade-offs. Here in this case, it's simpler to explain and it probably might work faster, but you are relying more about the surrounding words to get the context of the topic, for instance.
What about emojis? Like, for example, if the text expression is not obvious to be detected as a frustration or complaint, but there is a use of, the angry emoji on tweets.
Cool. Thanks, Yvonne, for that question. Yeah, that's the thing about doing text analysis is that sometimes when you're cleaning, you don't want to accidentally remove things that will actually help you inform later on. But then there's so much variability that can go on. For instance, like special characters or punctuation, which may later actually be emojis that give you important information. So one way to do it is you could actually go back to a dictionary method. So in other words, like you encode the emojis to mean something separately, and after that you filter through your text for that so that you have a separate set of data that actually lets you track like, okay, what kind of emojis are being used and what could it mean before doing like the standard pre-processing, which might then remove the emojis in the process of text cleaning.